Okay, good morning, everybody. We are back talking about logarithms. I'm excited for today's videos because we've been talking about logarithms, and last week we really kind of got into the properties of logarithms, how we can expand logs or simplify logs. Prior to that, we kind of talked about what a logarithm actually is and how it can convert back and forth between exponential form and log form. Today, in both of my videos that will be posted, we're going to talk about how now we can actually use logarithms to solve equations. And this is really when it gets kind of fun and you see the beauty and the power of logarithms as they apply to other areas of math. So before we get into solving equations, there's one last property of logs that we need to talk about. And this is something called the change of base formula. And this is something that is used to evaluate logs sometimes. And the property is right here. It says log base b of m is equal to log base c of m over log base c of b. The change of base formula basically lets us take any logarithm and rewrite it as the quotient of two logs, where we're allowed to just choose whatever base we want to here. Notice they just use a c and a c. That number could be anything that's not 1. And the base b in the original log becomes part of the denominator, and the m in the original log becomes part of the numerator. Now, why would we ever want to do this? Well, two reasons. Sometimes you want to evaluate a logarithm and the numbers are not nice that you can do it in your head, and you might need to use your calculator. However, a lot of calculators, their log button is only in base 10. So what this basically does is it allows you to change any log into a log that is a quotient of two logs with a base 10. Or sometimes we're given a log where changing the base becomes advantageous to us. So an example of that would be like here, part A. Log base 81 of 27. This is not something I can do right away in my head. 87 to what power equals 27? I'm not quite sure. But I might notice that both of these numbers here, 81 and 27, are powers of 3. So it might be nice here to change this log using the change of base formula and change everything into a base of 3. So I can rewrite this as log base 3 of 27 over log base 3 of 81. Right? Always remember that the base goes in the bottom, right? Base, bottom, they're both b's. Now, writing it this way, this is something I can evaluate without a calculator, right? Log base 3 of 27, 3 to the what power is 27, that would be 3. Log base 3 of 81, 3 to the 4th power is 81, so this log is equal to 4. And there, I just figured out that log base 81 of 27 is equal to 3/4. As I mentioned before, sometimes we use the change of base formula when the log needs to be evaluated using a calculator like this. 5 to what power equals 36? Well, log base 5 of 36 is not something that I would be able to do in my head, and even changing the base to something else like I did over here is not really going to help me here. So maybe I just need to type this into my calculator to figure it out. Let's use the change of base formula and rewrite this as log of 36 over log of 5. Now remember, if I don't indicate a base here, that means it's base 10. Log base 10 of 36, log base 10 of 5. And the reason I chose 10 is because on your calculators, I have my scientific here, you might have your graphing calculator, but on my scientific calculator I have this log button, and when I hit this log button, notice it has no base. What's really happening is it's base 10. So using my calculator, I can do log of 36 divided by log of 5. And now I'm able to evaluate this right there using my calculator and the change of base formula. So this is about 2.23. Now, some of you might have a graphing calculator where when you hit the log button, it does allow you to enter in a base. And that's nice. If you have that, that's great. But if you have an older graphing calculator or you have a scientific like this, your log button is most likely just going to be in base 10. Okay, so if you'd like, if I was you, I would pause the video for a moment and try part C and part D on your own, and then come back here and I will do both of those problems. Okay, if you've tried these on your own, I'm going to go ahead and go over the solutions. Log base 8 of 32. This is a lot like part A, where if I choose a nice base, I can evaluate this without having to use a calculator. I notice that 8 and 32 are both powers of 2. So let's rewrite this with a base 2. So I'm going to rewrite this as log base 2 of 32 over log base 2 of 8. Now I can figure this out. 2 to what power is 32? 2 to the 5th power is 32. 2 to the 3rd power is 8. Log base 2 of 8 is 3. So log base 8 of 32 is equal to 5/3. Part D, here's another example where these two numbers are not powers of the same base, so I would just like to use my calculator here. So I'm going to change this log into base 10. So let's rewrite this as log base 10 of 18 over log base 10 of 4. And then we grab the old calculator. Log base 10 of 18 divided by log base 10 of 4. And we get about 2.08. Okay, so change of base formula. This is a handy little property of logs. Sometimes we can use it to evaluate without a calculator. Sometimes it allows us to evaluate with our calculators. Okay, let's get into some of the good stuff here. So I want to show you one way we can use logs to solve equations. Here are 4 examples. All of these equations here, notice, are some sort of exponential equation, right? We have an exponent. Notice what's common about all of these. In all of these cases, our variable is up in the exponent. You maybe have not realized this before, but in all your time solving equations in your math classes, you probably have never really solved an equation where the variable is up in the exponent. You've certainly solved equations where the variable is the base, like when you have x squared, but it's very rare that we solve equations where the variable is up in the exponent. And the reason for that is to solve these equations, many times you have to use logs. So there's one property here that's going to be really useful. You might recall that in last week's video, we learned some different properties of logs, and there was one called the power property. And that's the property we're going to use in these examples. The power property says that if you have log of some base of some term that's m to the n, some term with an exponent, that you can rewrite that where you bring that exponent down to the front and it becomes n times log base b of m. These two expressions are equivalent. This is the power property. So this turns out to be incredibly useful when solving these types of equations. Let's look at part A. So in part A here, we have 5 to the 2x equals 20. Our exponent has our variable, 2x. Now what I'm going to do here is take the log of both sides of this equation. Right? A log is a function, so just like I could add something to both sides, divide both sides by something, I could raise both sides to a power, I could square root both sides, I can also take the log of both sides. So I'm going to take the log of the left side and rewrite this as log of 5 to the 2x equals log of 20. I'm just using log base 10, but I could really choose any base that I want. But I'm using base 10 because that's what's in my calculator. Now look what happens. I have log of 5 to the 2x. The power property says I can pull this exponent down to the front and rewrite the log like this. So that's what I'm going to do here. I'm going to pull 2x down to the front. And now this becomes 2x times log of 5 equals log of 20. That's a big deal because now we found a way to pull the variable out of the exponent down front, where now it's just a product. So I have 2 times x times log 5 equals log 20. We just now need to solve for x. So I'm going to divide both sides by log of 5. And I get 2x equals log 20 over log of 5. And then divide both sides by 2. And so I get x equals log of 20 over 2 log of 5. And now I have solved for x. And at this point, you're going to want to grab your calculator and let's enter this expression. And this would be our exact answer. Our approximate answer, we're going to have to plug this all in. Now this is why I chose log base 10, so I can just use my calculator button. I'm going to do log base 10 of 20 divided by, use some parentheses here, 2 log 5. Okay, and we get approximately 0.93. Okay, let's try another. 8 to the power of n plus 1 equals 3. Let's get that variable out of the exponent. We're going to do that by taking the log of both sides. So we'll do log of 8 to the power of n plus 1 equals log 3. Now, using the power property, I'm going to pull that exponent down, and I get n plus 1 times log 8 equals log 3. Now I'm going to solve for n. Let's divide both sides by that log 8. So we get log 3 divided by log 8. And the last thing to do will be subtract 1 from both sides. So n will be equal to log base 10 of 3 over log base 10 of 8 minus 1. And that is what I'm going to put in my calculator to find my approximate answer. This will be my exact answer. My approximate answer is going to be log of 3 divided by log of 8. And then we'll subtract 1. We get about negative 0.47. Okay. Go ahead and pause the video for a moment. I'd like you guys to try C and D on your own. See if you can do those two using this power property technique, and then come right on back and I'm going to solve these two problems. Okay, if you've paused and tried these, I'll run through the answers quickly here. So we're going to take the log of both sides. Use the power property. And now solve for n. Divide both sides by log 4. Last step is to add 2. So n is equal to log of 3 over log of 4 plus 2. If I type that into the calculator, I will get approximately 2.79. Last problem, part D. I'm going to take the log of both sides. And log of 245. Use the power property, pull that 2n minus 3 down. And again, start solving for n. So divide both sides by the log 15. And now we're going to have to add 3 to both sides and then divide everything by 2. So we're going to get kind of a big expression here, but that's okay, because in the end we're going to use our calculator. So if I add 3 to both sides, I get 2n equals log of 245 over log 15 plus 3. Now divide everything by 2. In fact, I could just kind of do this. Divide this side by 2, divide this side by 2. Ooh, so we get this kind of big expression here. That's okay. We're going to use our calculator to evaluate the whole thing anyway. So log of 245 divided by log of 15 equals that, plus 3 equals that, all divided by 2. Is about 2.52. Okay. All right, so this is our first solving technique for today, solving by taking the log of both sides and using the power property. Go ahead and move on to the next video where I'm going to show you 2 more ways that logs can be used to solve equations. All right, take care, everybody.